Modern operating systems support multi-user environments, and the processors support two modes of operation, which are the user mode and the privileged mode. In user mode, the user is granted access over a part of the system code, in order to protect the system from being damaged accidentally or by a malicious user. The user is normally capable of executing user applications, and granted actions are limited to prevent unauthorized access to the system or to any valuable information on it. The user mode is executed as a virtual machine within a controlled environment, in order to maintain the system safety, where each virtual machine is isolated from the others and is assigned its own memory space. The second mode is the privileged or kernel mode, where full access to the code is granted. Only components of the operating system are allowed to execute in this mode for security and integrity purposes. This concludes the topic of computer hardware related to the processor. The second essential hardware component is the memory, which refers to the storage required by the computer to be ready. It includes several types such as read-only memory, random access memory, and registers. The read-only memory is the memory that the computer can only read and not modify. This memory is usually burned on the chip by the manufacturer, and it includes the bootstrap information that the computer needs before loading the operating system. Being read-only, this memory is protected from any accidental or intentional modification or damage. However, there are kinds of read-only memory that allow administrators to modify their content to some extent, such as the following. The programmable read-only memory doesn't come with the data already burnt in from the manufacturer, but rather gives the user the option to burn in the information himself. The erasable programmable read-only memory allows an administrator to erase the content of the chip using ultraviolet light, and then be capable to write on it again. The electronically erasable programmable read-only memory allows the erasure of the content of the chip by applying voltage to its pins. The flash memory can be erased and written on at the same time in different sectors, and it is widely used in memory cards and solid-state drives. The random access memory contains information used by the computer during processing. The information on the RAM gets erased when the system is powered off, unlike the read-only memory. Critical data should never be stored only on RAM, to prevent a sudden power outage and a loss of the data. Real RAM memory is the main RAM storage resource, and should be refreshed on a constant basis by the processor. Cache RAM memory is used to enhance the performance of processing, which is achieved by moving the data that the processor is going to process to much faster memory. There are two types of RAM that systems use simultaneously, which are static and dynamic. Dynamic RAM uses capacitors that store charges, but should be refreshed constantly so the capacitors maintain these charges. Static RAM uses flip-flops, which are a form of switches that turns on or off, to denote a 1 or 0 bit, and only lose their value if the system's power is off.